Hello guys, welcome to this new video. In this video we are going to see about how to create a honeycomb design in CAD. So before getting into the CAD work, I would like to have a short introduction about honeycomb design. Honeycomb design is a structure which is a unique combination of strength, lightweight properties and energy absorbing qualities, making it valuable for industries where efficiency and reliance are crucial. The major applications of honeycomb design are in lightweight structures such as aerospace, automotive, bicycles, sporting equipment. When it comes to energy absorption and impact resistance, it is majorly used in crash protection, packaging, and protective equipments. When it is in thermal insulation, the heat exchangers, radiators, insulated panels uses the same design. And in construction and architecture applications, sandwich panels for floors and walls, furnitures, and building elements. When it comes to filters and airflow control, air and fluid filters, aerospace engine inlets, and some other applications. So these are the major applications where honeycomb design has been used. So let's get into the video. So before we starting this, I would like to show this is a Creo Parametric open bench, and I'm going to click a new command. So a new part body will be open in a solid type. So I'll just click OK, and I'm going to enable the planes, axis systems, coordinate systems, and points. So here I have three planes, right, top, front, and one coordinate system. In this, I'm going to create a extrude feature to have a parent body. So to click on the extrude feature, I'm selecting the front plane and I'm moving to sketch view. Here I'm going to create a profile. In such a way, and I'm going to constrain it. Let me make it parallel to this each and coincidence with this. I will add a symmetry for this feature with respective to the plane, and this total distance would be like 300. Angle as 135 degree. This I'm going to constrain for 200 mm. The same way for 200 here as well. Okay, let me constrain from here to here. That's 200. Okay, it's not happening. So before that, I'd like to have a value of angle here, 135 degree, and this length also will be equals to 200 mm. So this is 300. The height from this point to horizontal line is also as 200, and the same height from here to here is also will be considered as 200. Either you can go with the values or else you can give symmetric conditions for that. So here I have constrained all the dimensions here and all everything is in 200, and both the bend angles as 135 degree, yeah, as 135 degree, and the main parent flat as a 300 mm. I'll just click OK here, and the extruding value is in symmetric way as 20 mm thickness, and I just click OK. So next I'm going to add some rounds. I'm selecting the round command, selecting all the six edges, 1 2 3, sorry, 3 4 5 and 6. So for all the six edges, I'm going to give radius as 150, and for these two special corners, I'm going to give very minimal value like I'll go for 50, 50. Okay, let me reduce it to 25. Oh, sorry, 25. Yeah, this looks better. Kind of a half moon structure. I have made it in an extrude command. Now I'm going to create a extrude with a remove material for a honeycomb design. Next, I'm using the same extrude command for this feature. I'll go to the palette. I'm selecting 6-side hexagon. I'll just drag and drop it here and close this. Here we are going to define the value of this hexagon. I'm selecting this line to this line, placing here. The dimension would be like, I'm going to select for 15 mm. So from this, I'm going to give you a short clarity point. The next value of the next hexagon should be like, I'm going to draw a center line here, which is passes through this tangent points, and another center line here. The distance from the center line to this edge is half of the total value, which is 15, which is equals to 7.5. So the next value which is we given under this is equals to the distance, which is half of the value gap between one to another. So this value I'm going to give as 1 mm. So the total gap or the material between one hexagon cut to another hexagon cut will be as 2 mm, since we have given 1 in the half. So the total distance here is considering as 8.5. So please make sure this value by multiplying into 2, the value which will be gives you the result of spacing when we go for the pattern, which I'm going to show in the following. I just click OK here, make it as symmetric. The value will make it as 20 or more than that, 25, and remove material. Yeah. So an extrude has been created here. Now I'm going to fill this pattern over this entire material. So selecting this extrude, I'm going to click on the pattern command, and in type I'm going to select fill. In references, go to define, use the previous plane, and now project all the edge corners of the profile extrude which we have drawn before. So once you have projected all the lines, it will be looks like this, and just click OK. Here we are going to give the details of spacing, border, rotation, everything. So as I mentioned, that half of the distance of the hexagon is 7.5, and half of the gap between one to another is 1 mm. So the total will be as 2. Now we need to consider the 7.5 and 1 mm, where the total value is 8.5, and going to multiple this value into 2. So here value is, I'm going to give as 8.5 into 2, which is equals to 17. So this is the minimal value which we need to give. If the value is given less than 17, then one another hexagon will get merged and we can't able to achieve the uh, honeycomb design. Okay, even you can go less than this, like 16, where you will get a wall thickness between one hexagon cut to another hexagon cut will be as 1 mm in total. Here we are going to use 2 mm in total, that's it. And since the honeycomb design is going to get all over the profile, I just wanted to create a border here where I don't want some cuts like this in this edge corner. So I'm going to have the value in the border like 15 mm. So in all 360-degree, there will be a minimum wall thickness gap as 15 mm, which we have given here. The next condition is we are going to rotate the hexagon, because we need the top conical shape in the top side. So we need to rotate this profile in 90-degree. And the fourth point which we need to take care is the grid pattern. As of now, the grid pattern is in square, where we can able to see all the hexagons will create in a square shape. So the material which forms between one to another will be not like a hexagon shape. For your references, I'll just click OK now, and I'll show how it has been developed. Yeah, so once it has been developed, we can able to see, since there is a very minimal gap and it is in the square pattern, there is a gap has been created, and the material between one hexagon to another hexagon is not in a hexagonal shape, which is not in a honeycomb design. This is a wrong methodology to, so we go back to the pattern and we are changing the grid pattern from square to hexagon. You can use a diamond, so the material between one to another will be in a kind of a diamond. If you wanted to make it a circle, it will be like, looks like a circle radius, where you can able to see like this in a radius form. Next you can go for a spiral, and will be like a universe, and we can go for a curve or anything like. I'm going to select hexagon, where we are going to have a perfect honeycomb design in this. So please make sure these are the four parameters which we need to control while making a pattern in a full pattern. The first one is spacing, second one is rotation angle. If it is you have not rotated in the sketch view, then here we need to rotate, and the border, how much wall thickness you required in the edge corners, and the grid pattern is very important one. So these all the four parameters has been defined. Now I'm going to click OK, and we are going to see the results how it looks. Yeah. So once it is done, here you can able to see a honeycomb design pattern which is perfect one. Let me move to the front view, and the wall thickness between each and every hexagon will be considered as 2 mm in total, 1 mm in half, and the hexagons has been patterned, as well as I mentioned, since we have given the border value as 15 mm, we can able to see the material will be applied here. Make sure there is a sufficient material in all the corners. Please check the wall thickness between the minimal gap as well as on the maximum gap. Is it achieves your project's requirement? So in case if you're making any production or casing for any motors or some devices, honeycomb design will be the most sufficient and efficient design, where you will have a very good ventilation for the system, so the system won't get in heat, and will protect from the other damages. So please make sure to make a perfect honeycomb design, and I hope you guys have learned how to make a honeycomb design in Creo Parametric. Please try it once again from your side, and if you have any other doubts, please ping me on comments. I will definitely reply your comments. And also, please, if you like this video, please like, comment and share with your friends, and also subscribe to AK Technology Services. Soon we are going to launch our basic startup, and I'm going to give very long videos, more technology videos, and the knowledge about the engineering and the engineering insights. So we'll catch up in the next video. Please subscribe and follow. Thank you. Bye bye.